Hello everyone, my name is Marcos and today I'll be recording the second part of the AI platformer for GameMaker Studio because of timing problems in school, so Robert couldn't do this. I'll be doing the script that controls the AI. In the last part we did the player and the OBJ solid, so now I'm going to create a script that is going to be named, in fact I'm making it bigger so you guys can see it, and I'm going to call it rename. I'm going to call it calculate input. Okay, so I'm going to explain it just as I do it, because it's kind of difficult. So I'm going to create a variable named margin that is going to be equals to the x speed plus the sine of that speed multiplied by 5. This is the margin by which the AI, while moving, it's checking if there's something in this place. This is like kind of an x2, because the x speed plus the x plus the sine of the x speed times 5 is like a margin of view before it reaches the wall or whatever. Now I'm going to make another variable called above for checking if the player is if the AI is above or below the player. Now I'm going to make a variable that we didn't make because we didn't make the OBJ AI yet. So this is a variable we're going to implement into the AI that's going to be named xMove, and it's going to allow or don't the movement in the x direction. And now I'm going to say you are not going to jump. These are our initial values for these variables before calculating the actual value. So now I'm going to make an if statement checking if in front of the AI is a floor or not, and if there's a wall in front of it. I mean, if there's a floor and a wall. So now I'm going to type not place free x plus x speed times 0.5 and the y plus 1. And this is checking if there's not something in front of the player and on the floor. And place free x plus margin y. I already said what the margin was, and you can see it checks if a wall exists in front of the AI. So now this is going to be the big if statement. Yeah, so that's it for now, and I'm going to create another if statement inside of that one. That's going to be if the OBJ player dot y is less than the AI's y. This is checking if the enemy is below the player. Enemy is below the player. Now I'm going to calculate the fit. Well, before that, I'm going to make the else statement. Else if the OBJ player is dot y is bigger than the AI's y. That means the enemy is above the player. Else the enemy is at the same height, and so the enemy just has to move in the X direction, doesn't have to jump or check any walls, any movement, any strange movements, so just has to move in the X direction. So we're gonna leave it like that. And if the enemy is below the player, what we want to do is to calculate the fit of going to the left and going to the right. So I'm going to make a variable left fit, fit, and it's going to be equals to a function we're going to create now. And I'm going to make another variable right fit equals to. So now I'm going to make another script, create script called I don't know, jump sides. Why call that? Because the enemy is below the player, the enemy has to jump to get to the player. So we want to check which side is faster jumping to. So I'm going to create this function that calculates the fit to one of the two sides. I'm going to make a description for this. Description jump sides, and I'm going to give it an argument named sum. You're going to see why. I'm going to give it a function name. These Game Maker Studio 2 things are pretty strange and useless. I don't know why they implement it this way, but I don't like it. Jump sides, and now the parameter, it's called this way, param sum. So this way it'll show up as in Game Maker Studio 1. And now I'm going to create a variable called sum equals to the argument 0, and another one called so for example equals to 0. Now I'm going to create a loop, and I'm going to say while su is going to be like a counter variable until it reaches sum. So well, until it reaches something, not until it reaches sum, but I'm going to sum su, or I don't know how it's pronounced, until it reaches something such as a wall or a stair or whatever. So while not place meeting, while not colliding with something like this, but not place meeting x plus su, comma y, comma obj solid, and place meeting the floor, because we want to check like this, like if this has floor underneath, if there's a wall, and if below the wall there's a floor. And after that we want to check if the absolute value of x plus su minus the room width is less, is bigger than the room width. Why is that? If we have this plus sum that is bigger than the room size, than the room width, then it means the AI checked where it has to move beyond the limits of the room. So we want to break there and return -1. Then it means it failed. And else we want to sum so plus sum, plus equals sum. And now we break the while and we return the point distance from x plus sum comma y minus jump speed comma obj player dot x comma obj player dot y. Obviously, this is checking the distance between the point we just calculated and the obj player. So it returns that, and in order to use this function we have to pass an argument. That argument is going to be the direction of the check-in of the jump. So to the left side is going to be jump sides, and see, this is asking for a sum, as I said in the param thing here, pretty useless. In the jump sides I'm going to give it minus x and I'm going to give it, okay, I'm going to just, as we're going to use it many times, I'm going to make a variable called x sum equals 2 and y sum equals, I don't know, 5. So x sum, and the other one is going to be the same, but jump sides x sum. Okay, like that. Now we're going to use these fit variables to make a prediction to where has the AI to go. In order to do that, we're going to create another function. We don't have to do that, but I think it's more useful because we're going to be using it sometimes. So I'm going to call it useFit. This function is going to have two parameters. I'm going to add it at description use fit, left fit and right fit. It is important to write it like this way, because if you give it before the left fit, the right fit, it's going to change directions and it's going to go crazy, and we don't want that. So now I'm going to give it a function use fit for the name. Now I'm going to give it a parameter left fit and parameter right fit. Now we're going to create two variables. The first one is going to be the left fit. It's going to be equals the argument 0, and now the right fit, oops, I wrote right fit equals argument 1. So now I'm going to make another variable called fit sum, because we want to sum both of the fits. So fit sum is going to be left fit plus right fit. And if the fit sum is equals to -2, then it means both. I remember to you, I'm going to remind you, sorry, that if it returns -1, it means it went past the room width. So we want to check if both went past the room size width. So I'm going to comment it both wrong. And what we're going to do then is we're going to assume it wants to go left, and it's going to be equals to the obj player dot x being less than the AI's left the obj x's being less than the AI's x. Then we're going to say if the AI wants to go left, then the input of the AI must be right equals 0 and left equals 1, minus 1, I'm sorry. Else it means it wants to go right, so right equals 1 and left equals 0. Then if the fit sum was not minus 2, it means either one of left fit or right fit, one of those was wrong, or neither was wrong. So I'm going to check that now. Else if left fit equals minus 1 or right fit equals minus 1, I'm sorry, then one of both are minus 1. Why I did it like this? Why I didn't use the fit sum? Because the right fit, for example, imagine the left fit is minus 1 and the right fit is 30. 30 plus minus 1 is 29. That is not equals to minus 1, so we cannot use that. So we want to check if one of these two is wrong. So if they are, what we want to do is to check which one is wrong. So if left fit is equals to minus 1, then we want to say go right and don't go left. Else if right fit is equals to minus 1, then it means it wants to go left, so left equals minus 1 and right equals 0, and that's it. So the other case is that the both fits are valid, so we want to compare them. We want to make an else statement and check which one, which side wants to go. I'm going to assume it wants to go left again, and I'm going to say it is equals to the left fit being less than the right fit. I remind you, sorry, the left fit and the right fit are values that are the distance between the point we calculated and the player. The smaller the number, the fittest. So if the left fit is smaller than the right fit, then it wants to go left. And if it wants to go left, we want the variable left to be minus 1 and the variable right to be 0. Else it wants to go right, so right equals 1 and left equals 0. So that's pretty much it. Then we're going to save it, and I'm going to use it here. Use fit, and I'm going to give it the left fit and the right fit. Now we want to this is just one of 8 cases, but now we have the functions done. We just need 2 more functions, so it's going to be a long video, I'm sorry. I'm sorry, but I can't finish now because it's almost 20 minutes of video, so I will be covering the next few conditionals in the next part. It's not going to be as long as this one because we already have the most difficult functions done, and well, I hope you like this one and you find it useful and learn something new. And please, if you have any doubts, comment them down below and we'll solve them. And stay and watch the next video. See you in the next one. Goodbye.